Hi guys, BuildZoid here, and today we're going to be taking a look at another Z690 motherboard. This time it's the Gigabyte Z690 Aero D. The board was sent to me by Gigabyte, so big thank you to them for providing the motherboard. And unfortunately, I have no idea what the price of this board is, as it's like I've never seen it in a store. Like I've never seen it available for purchase. Which I think is really unfortunate because in my opinion this board has probably one of the best like feature sets of any Gigabyte Z690 motherboard, especially like I'm assuming it's supposed to be under $500. But yeah, I don't know. Like I've never seen the board actually in a store, so yeah, it's kind of hard to make a value judgment on when you don't know the price, but in terms of functionality, it does offer some really cool features. And also it's actually quite a capable overclocking board, so let's just get into it, shall we? So anyway, starting off with the rear I/O, where I do have one complaint for this board, and that's this right here. Like this only has 6 USB Type A ports, which it's an EATX motherboard, right? Like it's not super EATX, but it's a bit wider than ATX. So it's like I don't think, and you know we have this great big empty space right down the middle of the rear I/O section. So it's kind of like, I feel like they probably could have included a couple more USB ports, and I would have really appreciated that. I think 6 is honestly borderline for an ATX motherboard, and especially one that, you know, like I'm assuming this is going to be somewhere between $400 and $500. So somewhere in that range, the 6 Type A's is, yeah, not great. Let's just put it that way. However, for, you know, as a trade for giving up your USB Type A ports, you do get dual Thunderbolt 4 ports. One of those ports supports 60-watt power delivery, so I guess if you want to charge your laptop using your motherboard, you can. I think that's what that's for. I don't really care about Thunderbolt standards. Like this is not actually the part of the motherboard that I think is, well, I do think it's kind of neat. I just don't know what that's for. But yeah, so that's present. You have a DisplayPort input for display pass-through on the Thunderbolt ports. You have an HDMI output for the iGPU. There's Wi-Fi 6 from Intel over here, and then we've got 10 gig LAN from Aquantia and 2.5 gig LAN from Intel. So basically, in terms of different types of connectors, the rear I/O has everything. But I really do think it's kind of well, actually no, it's missing an optical output for the audio, and also the audio section's rather cut down. You only get a line out and like mic in. So yeah, basically this board gives you really great networking options, right, with the 10 gig and 2.5 gig, and then if you're into using Thunderbolt, you get like you get a lot of Thunderbolt, I guess. And you don't really get much else. So that's kind of unfortunate. It's not super terrible with the USB ports. Like 6, I've seen some ATX motherboards with 4, but like at that point, you know, like that's totally unacceptable. And 6 is pretty borderline in my opinion. So not a huge fan of the low number of USB Type A ports, but overall, at least if you're looking for like Thunderbolt or 10 gig LAN, well, this motherboard has that, so that's pretty neat. And then internally, you get 4 M.2 slots. These are all Gen 4. 3 of them are connected to the chipset, and this top one goes to the CPU. You do get PCIe Gen 5 switches on the motherboard over here, so you get X16 or X8 support on the primary PCIe slot, and then we get X8, well, X0 or X8 on the lower one down here. So if you wanted to run, like, I guess if you had a rendering workstation, you could use that for like dual GPUs. You could use that for capture cards. The funny thing with this board is like, you already have 10 gig LAN in the rear I/O, and you already have Thunderbolt in the rear I/O. So a lot of the, like, I guess you could put a Gen 5 SSD adapter card onto the secondary PCIe slot, or, you know, like, find something to put there. But yeah, like usually the kinds of things that you would use add-in cards for, like 10 gig LAN or Thunderbolt, like the board already has that built in, which frees up the PCIe slots for other activities. Personally, I'm just interested in the like multi-GPU setups for benchmarking purposes. But yeah, like it does give you a lot of options in terms of like internal expandability, because PCIe slots can be converted into basically anything. So that's cool. And actually one of my favorite features of this motherboard is the dual X8 support here. Then down here you get an X4 off of the chipset. Other than that, you also get 6 SATA ports, which is standard for Z690 motherboards. You get an internal USB Type-C connector over here, some USB 3.0. And that's kind of it for noteworthy connectors on the board itself. Now then, it also comes with some pretty neat overclocking features, which is the main reason, like, it's the combination of, like, dual X8 support. Like, basically, the way I see this is, like, Z690 Aorus Master, but with more connectivity options rather than, well, not really any connectivity options. Like, the Master is really, like, weird balance of features on that motherboard, in my opinion. Whereas this thing is much more flexible in terms of the feature set, but doesn't, and, you know, sacrifices a bit in the VRM department. We'll get to that. But not really in the overclocking functionality, because you do still get a postcode. So, you know, if you're doing memory overclocking, that's extremely helpful. But even more helpful than the postcode is this button right here, which is the rebindable reset switch. So this is the best thing Gigabyte has added to all of their Z690, like basically all of their Z690 motherboards right now. You can reconfigure this button to function as a safe boot button. So if you screw up your BIOS settings and it doesn't post, you can just hit the button and you'll go back to the BIOS at stock settings without losing all of your settings. So you don't have to constantly save profiles if you're like fiddling with memory settings, trying to, you know, really optimize something like that. And so this makes memory overclocking super, super easy compared to motherboards that don't have this button, which is a lot of motherboards. This is really not a very common feature to have on a board. Also, if you have the motherboard in a case and not on a test bench, they do give you a header for that reset, rebindable reset switch. So yeah, if you want to like rewire your front panel reset button to the safe boot button that you have on the board, you can do that. It also supports, I think, like direct BIOS boot and a few other boot options, but primarily, like the main, like honestly, if it was literally just a safe boot button, I would have preferred that. And by default, it acts as a regular reset switch. But yeah, so you've got that. There's also a Q-Flash Plus button, which allows you to update the BIOS of the motherboard without having a compatible CPU. Which I guess might come in kind of handy if they ever release the board, like if they release the board by the time 13th gen comes out, because again, it's not been in stores yet. There's some totally redundant troubleshooting LEDs over here, and they're redundant because the postcode exists. There's a clear CMOS jumper, and I believe that's that. So yeah, you basically get all of the sort of normal overclocking goodies, right? You get safe boot and you get a postcode, which is like the combination of these two things is pretty much as much like the sort of about as much as I really want from a motherboard. Like the safe boot, so you can tell, you know, how the motherboard is doing with the boot up process, and the safe boot button for when you can very clearly see that it's not making any progress. So yeah, this sort of nails it on the just, you know, overclocking extra functionality. Obviously, there's also like there's other motherboards that'll give you extras, but for like a daily system, I think this is about as much as you really need. For a benching motherboard, you know, there's other extras that I like to see, but yeah, for a daily system, I think this is, yeah, like this is feature complete to me for a daily board or a normie board. I guess most normies don't have much use for a postcode or safe boot button, but yeah, anyway. Let's move on to the power delivery, and here we have a rather wacky VRM layout. Normally you see most of the vCore VRM, you know, like over here, but Gigabyte decided to move that up for some reason and wrap it more. I guess that's why the board got wider. I'm assuming it just has something to do with getting all the different controllers into the rear I/O section. But anyway, in terms of power delivery, we're looking at basically the same VRM that you would get on a Gigabyte Z690 Aorus Pro motherboard. And so we've got VCC in over here, and that's a 2-phase. Then we've got a whole lot of vCore, and actually I will just put that over at the top. So we've got vCore, and that's a 16-phase, which is the same phase count as you get on the Z690 Aorus Pro. Then we get the iGPU rail over here, and that is just 1 phase, which again is the same as what you get on the Z690 Aorus Pro motherboard. So that's 1 phase. Anyway, the controller for the vCore and the iGPU rails is of course a Renesas RAA 22 9131, which is sort of Gigabyte's go-to controller for Z690 motherboards. I'm pretty sure they use it on basically every motherboard they have for Z690. And this is a 19-phase controller, and here it's running as... Actually, no, it's a 20-phase controller, and here it is running in a 16+1 configuration, handling the V-Core VRM and the iGPU. The other controller that takes care of the VCC in is this chip over here, and that is a Monolithic Power Systems MP2940, and that's a 2-phase controller handling the VCC in, so that's just running in 2-phase mode, because, yeah. Anyway, for the actual power stages for V-Core and iGPU, we've got a bunch of Intersil ISL 99390s. These are 90 amp smart power stages, and that 90 amps is a nominal thing. They're really not that different in terms of performance from 60 amp parts from Intersil. Yeah, so 90 amp smart power stages, and being smart power stages, they integrate current monitoring, temperature monitoring, and various safety features. Which is why they're called smart power stages instead of being just called DR-MOS components, because they have, obviously they have 2 MOSFETs and a driver, but they also have a bunch of smart functionality on top of that. Anyway, so the VRM efficiency, at least for the, power stages and inductors for V-Core, should be roughly the following figures. And that's for 1.2 volts output voltage at 500 kilohertz switching frequency, which the board does actually run at 500 kilohertz switching frequency. Gigabyte likes to use rather low inductance inductors because they give you better transient response. And so to some extent, you do need higher switching frequencies to sort of compensate for the ripple that those will produce. Though also with this much capacitance on the output, that doesn't really tend to be much of a concern. It's mostly just a case of like the higher switching frequencies with lower inductance give you better transient response. Anyway, so for 200 amps output, this VRM should produce about 15 watts of heat on the power stages and the inductors. 300 amps output, it should produce about 23 watts of heat. 400 amps output, it should produce about 34 watts of heat. And 500 amps output, it should produce about 48 watts of heat. So for regular usage, well, for overclocking 12th gen CPUs on like normal cooling systems, you're going to basically be between 200 and 300 amps, because past, well, honestly, even getting up to 300 amps is incredibly difficult in terms of CPU cooling requirements. The CPUs get very, very hot very, very quickly when you start approaching 300 amps of V-Core, current draw. And honestly, like, you could totally use this board for even extreme overclocking, as even 400 and 500 amps output. The VRM is really not kicking out that much heat, but at these kinds of heat outputs, you do sort of start needing a VRM heatsink. The thing is, if you're actually running the board on LN2, you're probably not going to be running multiple hours, like an hour of Prime 95, or really an hour of anything, as most benchmarks finish in under 10 minutes. And even with like 34 watts of heat output, it takes a while for a VRM to heat up. So, yeah, this, also I should mention that the board, does use an 8-layer PCB. And so basically, in the like normal day-to-day overclocking range of 200 watts, yeah, of 200 to 300 amps, the VRM basically doesn't even need a heatsink. It does come up with a very substantial VRM heatsink, but it's basically optional, because, yeah, the combination of having a 16-phase using these really powerful 90 amp smart power stages from Intersil with the fact that we're on an 8-layer PCB means that the VRM is really not going to have any issues, dissipating the less than like 1 to 2 watts of heat that it makes per power stage. Actually, it's not even getting close to 2 watts of heat per power stage, right? 2 watts of heat per power stage would be 32 watts. So yeah, in that 1 to like 1.5 watts of heat output per power stage, the VRM is going to handle that with basically just the surface area of the power stages and the inductors and the PCB itself potentially. So yeah, the VRM heatsinks here are, like, they certainly help with the operating temperatures, but they are optional, as this VRM is extremely overkill for anything that you can fit into an LGA 1700 socket. So that's the V-Core. The iGPU just uses another ISL 99390, and yeah, that's a thing. We're not really going to get into it. I don't really care about iGPUs. like, it'll power an iGPU just fine. I'm not sure how the iGPU behaves if you're overclocking. Like, yeah. Anyway, moving on to the VCC in VRM. So this is the same VCC in VRM that Gigabyte uses on basically all of their Z690 motherboards. And so obviously we have that Monolithic Power Systems controller, and then some Monolithic Power Systems power stages, because you know, you usually use the same manufacturer for both your controller and power stages. The only exception to that is GPUs, where you tend to find a really large mix of power components used, like different power stage manufacturers with different voltage controller manufacturers, which I should note, like Renesas owns Intersil, so these are technically like same company, even though it doesn't look like that at a glance. Anyway, the Monolithic power stages, Monolithic power stages that we're looking at here are MP87992s. These are 70 amp smart power stages, and at 1.8 volts output voltage, 500 kilohertz switching frequency. Oh wait, no, 800 kilohertz. Yeah, for some reason, Monolithic Power Systems decided that that's the switching frequency that they're going to rate their VRM at. So anyway, 1.8 volts, outputting 40 amps, the VRM will produce about 4 watts of heat. So, which is what you'd expect from most VCC-in rails. Also, the VCC-in rail should never ever have to supply even like 30 amps of power, 30 amps of current to the CPU. So this is also massive overkill, and the operating temperature of the VCC-in is going to be more dependent on the, how much work the vCore VRM is doing than on, well, itself. So, yeah, honestly, I'm really... Well, actually, for a motherboard in this price range, this is sort of a sensible VRM design. Like, this is what you expect to see in this price range. But the crazy thing is, Gigabyte puts this exact two-phase VCC-in VRM even on some of their really budget motherboards. Like, well below $300, and you still get this 270 amp smart power stages, overkill VCC-in. Whereas some other motherboard manufacturers below the $300 range, like, you're going to be looking at, like, discrete MOSFETs with... like with a controller that integrates the driver, like really cost-optimized solutions, which this really isn't. I mean, it doesn't really matter on a board like this, but yeah, it's interesting that Gigabyte is sort of just copy-pasting the VCC-in VRM so much. Anyway, let's talk about the filtering for vCore, as VCC-in I don't really care about. There's an integrated voltage regulator for that, so all of the actual heavy lifting in terms of voltage regulation is done inside the CPU, not on the motherboard. But for vCore, the motherboard actually has to sort of, do a good job of regulating the voltage going to the CPU. And to that extent, I already mentioned we have the 150 nanohenry inductors, which help with transient response. And then for the output filtering bulk capacitors, we've just got some Nichicon FP caps. These are rated for 10,000 hours at 105 degrees Celsius. They're 6.3 volts, 560 microfarads each, and there's quite a few of them. Yeah, there's not like this is kind of what you'd expect to see on a Z690 motherboard. However, the big difference with this board compared to a lot of the other Gigabyte Z690 motherboards, and for example the Z690 Aorus Master, is that on the Z690 Aorus Master you would actually have some tantalum polymer capacitors in this area of the board to just sort of offer a lower ESL, lower ESR capacitor for dealing with transients from the CPU. Now, we don't have this on this motherboard. And similarly, on the back of the board, on most of the Aorus motherboards, you would get, I think it's like 4 or 5 tantalum polymer capacitors sitting inside the actual CPU socket, inside the CPU socket cavity. But with the Aero D, we actually just have a bunch of multi-layer ceramics. And interestingly enough, this has no difference in terms of actual voltage regulation performance. This makes no difference. Yeah, so like I've measured the voltage regulation of the Z690 Aorus Master and the Aero D board, because this is one of the more obvious differences between the two boards physically in terms of power delivery. The Master board also uses like higher current power stages, and it's also a 19 phase instead of a 16 phase, but honestly none of those really matter. because this VRM is already perfectly capable of powering any 12th gen CPU. And so the main difference to me was like, okay, so this has a rather different capacitor configuration compared to the master. But in terms of actual voltage regulation performance, that does nothing. Like, absolutely nothing. And that also includes the Z690 Aorus Extreme board. So yeah, I've taken oscilloscope measurements. This has the exact same voltage regulation performance as the Z690 Aorus Master. And so if you do actually manage to find one of these boards in a store and you're sort of, making a decision between buying a Master or buying this, well, this has Thunderbolt, 10 gig, 2.5 gig, right? Like a lot more connectivity options than the Master does. And voltage regulation-wise, it performs the same. The VRM is fine. So really, I don't know why the Master exists. Because yeah, it's just like, I've not been able to measure, like, the CPU overclocking-wise, this performs the same. So I don't know what's going on with that. Well, I'm not sure why Gigabyte has these two boards, and then why this one's so difficult to find. Because in my opinion, this is just the better board. You've got a much, more interesting feature set, and it's not like you're sacrificing anything. Like, on paper, it looks like you might have slightly worse voltage regulation, but from actual testing, it's like, nah, it's exactly the same. So yeah, which I also find very interesting. I think with the with this Renesas controller, like I'm assuming, and also maybe the combination of the really low inductance inductors, the VRM is just so good from the get-go that it's not so dependent on its output filtering configuration, and so that's why even, well, I'm not sure. You also have like on the top side of the board, they're both the same. The Master uses the same multi-layer ceramics on the top side of the board for output filtering as the Aero D does. So I guess it kind of makes sense that the difference of like having 7 tantalum polymers versus having a bunch of multi-layer ceramics, and we're just going to call them a bunch because I'm not going to count them. It just doesn't really, it doesn't really end up being much of a difference. I think the total capacitance is probably slightly in favor of the Master, but having more capacitance isn't necessarily going to give you better results if that capacitance also isn't fast, like if those capacitors aren't fast enough. And multi-layer ceramics are way faster than everything else. Well, depends on which physical size multi-layer ceramic capacitor we're talking about, but 0805s like this are significantly faster than SMD polymers like this, which Gigabyte did still put one in here, but this one isn't the usual Panasonic pos caps that you see on the Aorus boards. This is a aluminum polymer from APAC, and it's slightly worse electrically than the pos caps from Panasonic. So yeah, but again, like from an actual real world testing results, it's like, no, they perform the same. So evidently the controller and the power stages and the inductors are already doing such a good job with the transient response that the output filter doesn't seem to have too much of an effect between these two boards. Well, actually, the thing is, I've also tested the Tachyon, and that also performs the same. So actually, the controller just doesn't seem to be too affected by what output filter it's attached to, and potentially the CPU socket is just, being such a bottleneck to any transient that is, that starts at the CPU and then has to get towards the actual motherboard, that really high frequency or faster output filtering capacitor configurations on the motherboard itself just don't make a difference anymore. Because any transient that would be actually fast enough to register the difference between tantalum polymers versus through-hole capacitors versus what we have on the Aero D never actually makes it out of the CPU socket, right? It never actually gets to the board, and so the boards all seem to perform the same. That's my theory on why the measurements are working out the way they are. Yeah, anyway, let's talk about the input filter, shall we? Which is the same as what you would find on a Z690 Aorus Master. Interestingly enough, it is different from what you would find on a Z690 Aorus Pro, which I find really interesting. The Aorus Pro board has, off the top of my head, 8 through-hole polymer capacitors from Nichicon, FP caps, of course, again rated for 10,000 hours at 105 degrees Celsius. And this has 6, which is the same as what the Master has, and I'm really confused as to why the Z690 Aorus Pro board has the largest bulk capacitance for input filtering out of any of the... Well, I think the Tachyon has more, but out of the sort of mainstream Gigabyte boards, yeah, I'm really confused by why the Z690 Aorus Pro has the most capacitance, because it's like, yeah. Either way, in terms of voltage regulation performance, all the boards seem to be performing the same, so the Renesas controller is evidently just doing a really good job with the voltage regulation, and I wouldn't be too worried about the input filtering. We also have an input filtering inductor over here, which is the same inductor as used for the VCore VRM itself. So anyway, that's the VCore VRM on this. It's nothing particularly, well... A few years ago, if your motherboard had this, I'd say it's actually very fancy because we've got 90 amps more power stages and there's like a 16-phase controller, but these days this is just kind of the norm for high-end motherboards to pack VRMs like this, and so it's a pretty generic Gigabyte high-end Z690 VRM to me, and so yeah, and there's nothing wrong with that. It's a very good VRM, great voltage regulation, perfectly capable of powering any CPU you can fit into the socket. It's just a bit boring compared to, I miss the days of old motherboards where the motherboard manufacturers had all these different VRM designs. Not that it was not that those VRMs were necessarily good. It was just more interesting to look at. Anyway, let's talk about the memory overclocking. So as I mentioned earlier, the board does use an 8-layer PCB and uses the exact same shielded daisy chain memory topology that we see on the Z690 Aorus Master and Z690 Aorus Extreme. So basically that means this board is so obviously being a daisy chain topology, you should use only the last DIMM slot of each memory channel. So the board favors 2x8 configurations. Well, actually, don't get 8 gig DDR5 DIMMs. They suck. I'm still mentally stuck in DDR4. 2x16 is good. 2x32 is good. The problem with 2x8 is that the performance is terrible because of the way the memory chips for the 2x8 chips, for the 2x8 memory sticks, the memory chips, well, for 8 gig memory sticks, the DDR5 memory chips suck. Anyway, so 2x16, 2x32 are sort of the memory configurations that you should really be trying to get for this motherboard. In the future, we should be seeing also 2x24, 2x48, and eventually I imagine we'll see also 2x64. Anyway, in terms of actual memory overclocking, expect this to top out somewhere around 6200-ish. Yeah, and technically this topology is capable of booting and running benchmarks all the way up to 6600, 6666 even, but stabilizing it at, I've actually managed to run memtest at 6400 on this memory topology a few times. However, it is super inconsistent. Yeah, sometimes you can get it to pass stress tests. Most of the time, it doesn't. And it really is, it's completely random, reboot to reboot, how much stability you have at those higher memory speeds. And this seems this has been my experience with all of the daisy chain boards, is just, also, I didn't write chain anyway. Yeah, so all of the daisy chain motherboards, the thing is, DDR5 is just running at such high memory speeds that, the extra DIMM slots are really harmful to signal integrity. As they basically act like unterminated signal lines. So, yeah. Anyway, but also, so memory overclocking wise, this is as good as it gets for Gigabyte daisy chain motherboards, because the next, if you want a better memory topology, the only other option you have from Gigabyte is the 10-layer 1 DIMM per channel topology of the Tachyon, and then as far as the others, the Aorus Extreme uses this exact same daisy chain with the exact same issues. The Master uses this exact same daisy chain with the exact same issues. This uses the 8-layer daisy chain. I don't believe Gigabyte has any other 8-layer boards. The Aorus Pro and the Ultra are both 6-layer PCBs, so those clock even worse. And then that's kind of it. It's just like, welcome to DDR5. It's clocked so high that it really doesn't work very well on 4-DIMM motherboards. And there's not really anything you can do about that. Maybe in the future we'll have memory controllers and memory sticks that are better, but with the 12th gen CPUs so far, the daisy chain boards really just, you're basically looking at around 6200 plus minus like 200 megabits per second. And if you're on a 6-layer board, you can take like 200, 400 megabits per second off of that. So yeah. Anyway, that's the Aero D. Yeah. A really, really cool feature set. I kind of wish they had a DDR4 variant of this board, because especially because this is meant to be like a creative motherboard, and a lot of people who do like video editing or rendering or something, like they want a lot of RAM, and 128 gigs of DDR5 is a terrible idea. Like, it will not work properly. So I really think a DDR4 variant where like 128 gigs of DDR4 works great, actually. Like, you can get memory sticks, you can get 32 gig DDR4 memory sticks that work really, really well. They clock well, they don't have weird stability issues, and they're great. Whereas with DDR5, as like the boards don't even QVL 32, like 4x32 configurations at all. Like, you're just not supposed to do that, as far as I can tell. If you look at Intel's own documentation, it says that if you're trying to run a quad rank memory setup on like 12th gen CPUs, you're going to be stuck at DDR5 3600. At which point you may as well just get DDR4 instead, because you might actually be able to run higher memory speeds on DDR4 at that point. So yeah, that's basically. So that's my two criticisms of this board, is like, I kind of wish there was more USB Type A ports, also an optical output for the audio. And then I wish there was a DDR4 variant, because 128 gigs of DDR4 is not awful. Whereas DDR5 really doesn't seem to play well with high density memory configurations right now. And yeah, so it's kind of that. Also, good luck getting 128 gigs of DDR5, right? That's another issue, but yeah, other than that, the feature set's really, really cool. Overclocking wise, it's basically a Z690 Aorus Master with more features. That's the best way to describe this motherboard, and that's the main reason I actually asked for a review sample of this board. Also because I want to run multi-GPU setups, and I don't want to use the Aorus Extreme, because I think that motherboard's really dumb. So I don't want to give it screen time. Anyway, yeah, that's it for the video. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, hoodies, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel, so it would be really appreciated if you check them out. And that's it for the video, so thank you for watching, and goodbye.